Right, we ready? Okay, we're going to have a look today at some physics. We're going to have a look at electrical charges and fields. We're going to have a look at Wimshurst machines, Graaff generators and the like. We're going to have a look at electricity in its pure form. So I want to have a look at basically what is electricity. Many students I talk to, they seem to think there's a difference between something called static electricity and, well, normal electricity that comes out of the mains or comes out of a battery. But in fact they are one and the same thing. It's just that when we use and talk about static electricity, we're often talking about electricity that can't move. It's the electricity in insulators as opposed to the electricity moving around wires. So let's get started and see what we can find out. I've got a few different bits and pieces to have a look at. You can see from the Graaff Generator all the bits and pieces that we've got here. We've got some little rods to have a look at, and I'm going to try and balance this rod up. And I've got a couple of different rods. I've got some acetate rods and I've got some PVC rods. Let's have a look at what happens with some of these. So I've got my PVC rod. I have borrowed my wife's silk scarf, and what I'm going to do with this silk scarf is I'm going to charge up this simply by rubbing it. Now as I rub it, I'm going to rub either the electrons off of the piece of plastic, or I'm going to rub them off the piece of silk. So there we are. Let's just leave that. Now I have a little meter here, and this tells me what sort of charge I've got. Green for negative, red for positive. If I bring there, I can see that it's actually going to have a few problems. We'll try it on a piece that I can hold. It might be easier. So let's give this a brief charge, and this indicator will tell me whether it's negatively charged or positively charged, and it appears to be negatively charged. If this is negatively charged, then it's going to repel. Now bring it close to it, not touching, and we can see that these charges, which are the same, both are negative. Got negative here, got negative there, I've got positive that side. That's the problem I've got. So both are negative, and here the charges are repelling one another. There we are. We can see quite happily these are repelling. Let's take a different material. This is some acetate. And let's just see what happens here. Try and get it to stop. Ooh, that appears to be attracting. Here, not working terribly well, but it's coming up positive there. And there we've got some attraction going on, as opposed to the other one doing repulsion. What would happen if we swap them over? So let's take this piece of acetate and I'll try and balance it reasonably well. There we are. And let's charge this up with a silk scarf. So it appears that this one seems to be positive. Right, so I've given it a good rub there. So if I take a piece of acetate, it should be light charged. So light charges should repel. And we can see that it is repelling. And if I charge up a piece of PVC here, this should become negatively charged and should hopefully attract. Well, that's repelling. So opposite charges should attract, light charges should repel, and it appears this is certainly repelling, so it's charged the same way, and this one is also repelling, charged the same way. Well, that wasn't quite what I expected. Let's take that off. We can look at a similar thing. This is a piece of ebonite, and what I'm just going to do is I'm going to wrap this round here. I'm going to get that there. And I've got another piece of ebonite. I'm just trying with different materials. Let's give it a good rub. Some materials charge better than others, and they charge different things better. So let's give this a little charge and see what happens. And we're getting our light charges repelling. I can actually touch these things. Transfer the charge that way, but we seem to have, certainly here, repulsion going on. Got a plastic rod here. I think it's acrylic. And certainly we've got a traction going on here. And I have another rod. This time this is glass. And this doesn't always work. It depends what you charge it up with. This rod is certainly twisting lots. Just try and steady it for a moment. Let's see what this is doing. Doesn't seem to be doing much, this one. It doesn't seem to be neither attracting or repelling. maybe I've got the wrong substance. Let's try some wool. No, I've got some polyester. And glass and polyester, they are charging. Perhaps not that well. So we've got different materials, and these all store charge on them. Be the charge positive or negative. Okay, so we started off with that, and that's the important fact that we need to get from this lesson. We need to know that like charges repel and unlike charges attract. I suppose it wouldn't hurt to write that fact down for us. And this is the crux of what you need to know, and what the exam questions were probably going to be all about. If we've got a rod that's suspended here, and it is negatively charged, then if I bring in another rod which is negatively charged, then this one's going to move away. So we can say that like charges repel. And in exactly the same way, if we make this one positive and this one negative, we can say that unlike charges attract. So that's the important bit to take away from the lesson. But of course there's a bit more fun we can have with some of these things, with some of these properties. So let's have a little look at some of these ideas. So the first of these ideas I've got is something called a Wimshurst machine. Now, you've seen the Graaff generators before, but not so many people see these. And I'm going to keep the camera a little bit of a distance away from this. We'll zoom in, but we're going to keep it a bit of a distance away. And the reason we're going to do that is this produces some static electricity. And when I mean it makes some static electricity, I mean it makes quite a lot. Now, what I've got here are some wheels, and as I move this wheel round in one direction, so the other wheel moves in the other direction. I've got some little contacts here that are going to pick up the electricity, and this here going to pick up electricity, and it's going to send these to these two Leyden jars. Now the Leyden jar basically consists of a piece of basically a glass tube with some foil on the inside and outside. It's just going to store the charge, and it's going to be connected to these little rods. So this is going to be storage of the charge, and here two little rods. These represent my Graaff generator dome. Let's see what happens if we turn this. And if I turn it one way, I can feel my hair on my hand stand on its edge, and I can see this spark What's happening? Let's make the gap a little bit bigger. Further away, I get less sparks, but they do seem to be larger. I'm not sure you can see that. Maybe you can see these easier. And hopefully you can hear them. So we've got our little Wimshurst machine, surprisingly made by a guy called Wimshurst, and this machine generates a large amount of static electricity, and we can demonstrate some of these bits and pieces with some interesting experiments. So let's have a look at one of these. Now I'm going to charge this up, and I'm going to bring this little ball near. I'm trying to hold it still, and it's bouncing from one to the other. Right, now we get the spark here. Let's suppose I put these a little bit further apart. Let's charge them up. No spark. But let's bring this ball nearby. And I'm not trying to move this ball at all. And it's moving. Let's make them a little bit further apart. And as soon as I start turning this, my ball is responding. Something's happening with the charge. So, a Wimshurst machine. It's quite a good fun machine to play with. But in fact, when we want to try and play with this, what students like to see is this one. And this is the Graaff Generator. Now, the Graaff Generator produces quite a lot of we had a little problem there. The Graaff Generator produces quite a lot of static electricity. Let's just see how it's going. So let's turn it on. And you can see we've got a much bigger spark, many more volts going. And you can see that the second bulb has actually moved. Yeah, we are moving a little bit further away here. Do you want to plug in elsewhere? So we're just readjusting the room to get the camera far enough away so it's not suffering from the effects of the Graaff Generator. I'm just going to turn this off for a minute. And I'm just going to get rid of the spark. And what we're needing to do is that we didn't have time to practice this before we started, so we've just moved the camera back quite a way, fact, Paul's going to move it back as far as he can and then zoom in. Right, are you back on? Yep, okay, so let's put the camera back on. Right, so you can probably see he's quite a lot further away. And I'm going to turn it on now just to see if it's going to affect the camera. And now Paul's got some better pictures at a further distance, and you can see some of the sparks come through. There are a spark for every bang, however we are getting you not to see all of those, and the reason that's true is the camera working, and there's a fair bit of static electricity going on here. Right, let's have a look and see what we can do with this static electricity. Now, we'll get the ball out and have a look and see what we can do. So I've got these two spheres, I've got my other ball, which I'm just going to hold absolutely still and see what happens. Right, I'm stopping there because I'm getting a bit charged up, and that doesn't appeal to me an awful lot. Right. We've got a few experiments we can have a look at. The experiment I really wanted to do was to have the person with lots of hair and nice long hair, and what we can do is we can charge them up by getting them to hold on to the Graaff Generator and charge themselves up. Alas, I don't have a volunteer to do that, and I'm follically challenged, so we're going to make use of this instead. Let's have a look about what this Graaff Generator is all about. It really is very simple. It consists of a rubber band, and it runs over a roller and another roller. There's a pickup here which Paul can show you, and that picks up the electricity. That is then transferred to this piece, which is connected to the dome, and that picks up, and this gets covered in the charge. So this becomes either positively or negatively charged. I could tell you which, simply by using my little meter. And this ball is earth. It's set to the opposite, so it's the green earth here. And so what happens is the electricity basically builds up on here. It's got a big surface, so more charge can build up until it's so large, and it's a nice day today, so it's quite dry, and so the spark can then ionise the air and jump across from one to the other. Well, at the top here I've got a little hole, and I've got my little piece of simulated hair, and I'll just spread it out. Right, let's see what happens if we switch on. What I'm seeing is this hair. If I discharge it, you can see that it's moving. If I build it up, it should sort of try and spread out as much as possible. And if I let's discharge it, it all goes back as it was. And I can show that it is still slightly charged on there by those hairs sort of touching the ball. By getting these two to touch, I discharge this. There is now no electricity for me to feel when I grab hold of it, and it's safe. So not as good as trying the young person with the hair, but it's probably a little bit safer. My favourite experiment was usually to involve some students touching this, and always sort of put them in buckets and insulating them from the ground, producing something. Now, this experiment took extreme sacrifice. Some poor soul had to eat all of those apple pies, and my son did rise to the challenge to eat all those apple pies so I could have all these apple pie lids. And this is quite a pretty experiment. I quite like this one. It's one of my favourites. And each of these aluminium tins lids will become charged. The electricity will go on there. The charges then will repel, and let's see what happens. So let's build the charge up. Here we go. And if you manage to work really well, you've managed to charge that so it sits on the side, attracted to the wood. Right, so the only problem with this experiment is I end up with a load of these to pick up. As you see, it was quite good fun experiment. I've just got a lot of dishes to pick up. Right, okay. Just get these out of the way. Right. What I want is someone magically to appear under the sort of stage and sort of take all those things away from me, and then I turn to the next experiment. Perhaps when we get a slightly larger budget. Okay, let's see what other things we can look at. We've done the experiment with the pith ball. Here is the same experiment. This is just called a Faraday's pail here, and I've got a little pith ball, and if I charge this, it will move away like charges repel, and if we release this charge, you can see it moves back down again. Faraday's pail. Same sort of thing. What I've got is a metal lid. We've got a plastic tube. And a little metal plate. So let's take the little metal plate, put onto it a plastic tube. I've got some balls of aluminium foil. I've got a lid on the other side. Let's see what happens as we turn this on. Some of them are picking up charge. Light charges are repelling. And sometimes when we get this going, they're building charges that are repelling. And sometimes they bounce right to the top or not. And not so well today to try and get the charge coming off. There we are. We'll try a couple of interesting experiments. This one is a needle, and I've got on here one of these little discs, and if we can stop it moving, so it's not moving really, I'm going to start the Graaff Generator up. And we can see that it immediately starts spinning. And in fact it gets going at quite a rate of knots. We can have more fun with this. Let's now take this off, and I'm going to risk life and limb, because what I'm going to do is I'm going to hold this. Paul's just going to adjust the camera so we can see what we're doing, and let's turn it on. And as I bring it nearer, it starts to turn. And I can feel the electrical force. I can feel the static force around, the static electricity being generated. Okay, so that worked. Now I've got another experiment which I've got, which is a little bulb, and if I bring that close it's going to light up, well, hopefully. But that's not as good as doing it this way. What we're going to do is we're going to try and demonstrate this working with a fluorescent tube. This is a working fluorescent tube. I've just taken it out of the light, and we're going to see what this can do. Now we're going to turn the lights out a little bit, so hopefully you can see a little bit better what's going on. I don't want to make it completely dark, but I want enough that you can probably see. I'm going to hold it about halfway down, and let's see what happens. Yeah, I got this up a shot then, and with a bit of luck you might see this light glowing every time there's a spark. You'll also see it moving. This is the involuntary moving. If I hold it further up, there you can see. But you notice it's not going down below my hand. If I move my hand further down, it's still going down to only where my hand is. We'll put the lights back on. And I'll put the bolts up safe. This gives quite a bit of a kick out. I can feel this, I haven't discharged it now, and I can feel the hairs on the back of my arm rising up. I don't know if you can see this, so you try it. So it's got some charge there, and you might see the hairs on the back of my hand, my arm, sort of being pulled up. I'll pull them down to bring them back, and you can see they're being attracted, hopefully. It certainly does give quite a little kick. So there is our Graaff Generator. I've got here a different experiment, and I'm going to do this one twice. Years ago, people prized special jewellery, and here's my piece of jewellery. This is a piece of rather nice jewellery. Just getting rid of a bit that broke off. This is amber, and what people noticed with amber was that as they tried to clean it, it actually seemed to get dirtier. And I've got a little bit of paper here, some little paper squares, and if I rub this, we might find depends what I'm rubbing it with, of course. My lab coat, obviously not the best thing. Let's try a bit of wool. And I've got some bits of paper sticking to this. They have to be fairly small, light pieces of paper. But they are being picked up. It's the same principle we met before, the electrostatics. Here the particles are charged oppositely, so they are attracted. Well, we can do the same principle here with a confetti machine. So let's see if we can try and make a confetti machine. This is not one of my most popular things that I do. It's certainly popular with the students. It's not so popular with my wife. And what I'm going to do is I'm going to take a little bit of paper and I'm going to put this in here. I'm trying to make sure all my bits of paper aren't stuck together. And this is my confetti machine. I have thought of trying to bring this to the markets for weddings. It might be rather good fun, but we'll see what it is. Right, so we turn the Graaff machine on. and at the appropriate moment I pull this away and my confetti is spread all over the place. It's all over the floor, it's all over the unit here, and it's still stuck to the wood here, which makes really quite a lot of mess. It's one of those really quite messy experiments. I got a few pieces still left in there. So not terribly popular with my wife, who just comes in and says, "This is a mess, clear it up." She doesn't, by the way, clear it up. She just tells me it's a mess. Why don't you clear it up? I made the mess, so it's only fair. So we've got a few experiments that we've looked at, looking at the Graaff Generator and looking at the Wimshurst Machine. These are basically the same. They do the same thing. The only difference is scale. If we combine these two together with much bigger spheres, then this is perfectly good. I like this one in that it shows that it's not electrically driven. It is just by turning this that I can get a spark. So we've got here this idea that static electricity can be generated. Where else do we see static electricity generated? Well, it's fairly obvious, I hope, that the other place we get is my fluffy cloud and the sky, and we can either get static electricity building up in the cloud and we get lightning inside the cloud, or we can get it moving to the ground. And the spark is our lightning and the sound is our thunder. And as you were hearing when we got this working, you could hear some sound, and that sound was causing the thunder. Yeah, alright, so it wasn't very deep and low. That's because the sparks were fairly small. As I got the sparks larger, so the spark note got lower. And if we can send it a long distance, then the note is particularly low and it sounds very much like thunder. So that's static electricity. The insulator's electricity, the fact that electricity is building up on an insulator sitting on one side and it can move to the other. I wasn't brave enough today to do my favourite party trick, which was one that I did always to start my introduction to year 7s on how to light a Bunsen burner. Yeah, it's a trick, and what I used to do is I would sit on my chair in a pail, so my feet weren't touching the ground. We would have previously charged me up with a Graaff generator. So when the students came in, there was I sitting at a desk, and on the desk was a Bunsen burner connected to the taps, and I would get one student to come up and make sure the hole was fully closed, then to turn the tap on, and then I'd show them how to light it by simply bringing my hand close to the Bunsen burner, and a spark would be generated and it would light the Bunsen burner. For many students, they believed that was how I did light a Bunsen burner. They never saw me light one again, and they all thought it was quite a cool trick. And I didn't let the cat out of the bag telling them about the Graaff Generator that had charged me up prior to them coming in. It was quite a good fun experiment, and one, maybe most of them worked out how it happened fairly quickly. Right, so that's it for today on this. I hope you enjoyed that. I hope you found it useful, and if you did, please subscribe, and I'll see you next time. Bye bye.